about this talk. She'll be talking about Atlas, the Institute for Radical Creativity and Invention that synthesizes design and technology, amplifies innovation in engineering and the arts. They believe that the best way to shape the future is to invent it, promote rigorous, curiosity-driven investigation in a thriving academic community that is supportive, energetic, and playful. It all sounds very exciting. So I would like to give a warm welcome to my good friend, Ellen, who has joined Cadrea since the very first year of Cadrea. Please have a round of applause to Ellen.
Hi, everybody. Can you hear me? So I don't have to do sharing, it's already happening. Okay, so good morning, everybody. It's actually evening for me. If you have any questions, please put in the Q&A session because I won't be able to see any chat and nobody can see the chat. So put in the Q&A and then Surapan would handle that. Okay, let me share my screen. You can all see my screen, right? Good. Okay. So the topic today is about making magic with creative technology and design. So first question is, why do we want to talk about creative technology and design? Well, there are a couple of reasons. Because we all care about our world. We are doing design computation. And we are talking about cross-disciplinary creativity. And I'm also happy to tell you that at the Atlas Institute, we have degree, bachelor, master, and PhD in creative technology and design. So the first question you may ask is, what is creative technology and design? So similar to what we are thinking about design computing, we can talk about computational support, we can talk about systems, visual, computation, artificial intelligence, BIM, all of that. But I think the important thing is that we, as a researcher, we build things. We build physical and computational artifacts. We are building objects to think with, and this is a way of working. We are interested in making methods and tools to help people make things. And there is this key concept about creating magic. So what do I mean about magic? All right, so I think some of you may know about the movie 2001, right? Space Odyssey. So Arthur Clarke was credited for helping the movie plot, but he was also a science fiction writer and the inventor of the communication satellite. And I really like his quote because he said, any sufficiently advanced technology is indistinguishable from magic. So we can think about a lot of things when they first come out. It's like magic, right? The first car without horses. People say, wow, that's magic. There's no horse, the car can move. When we got the electricity moving, we can now just turn on the switch. Oh, the light come on. That's magic.
Hi, sorry, Ellen. There's a pop-up window in front of your screen.
There is a pop-up window in front of my screen.
That says opening the keynote presentation. I don't know if you see that. It's right in the middle of the screen.
I cannot see that.
Can you, yes. And maybe start again, sorry.
So if I do that, so you cannot see it at all? Do you still see the screen?
It's still there though.
Okay, so where is it? Okay, let me try it again. Share the screen.
Sorry about that, folks. This is how technology works. Can't live with them, can't live without them.
Because I cannot see the screen. That's interesting. Okay, how about screen sharing has failed to start. Please try it again later.
Okay, we do have a backup.
Or how about try again, share screen. This is the screen, share. So you can see, but then when I hit play, you have an extra screen.
We have that pop-up window in the middle. But I guess that's, we can endure that for a while we open our backup.
Or can you, so you can see my screen right now. There's no pop-up, right?
Right, you can show this screen instead.
Okay, so I can, when I do play, then you have a screen, but I cannot see it. That's funny.
Right.
Okay. All right, so 1, 2, 3, 4. So I'm talking about magic. I'm talking about Arthur Clarke, talking about technology. When you do technology, if that's advanced enough, then you feel like it's magic. Okay, so of course, I would like to invite you to come visit Atlas Institute at Boulder in Colorado. So Colorado is in the middle of United States. Okay, when you come, you will see our building. And Atlas is an interdisciplinary institute for radical creativity and invention because we are curious about things we're doing, interesting stuff, thinking, research, experimentation. And this is what we think we are doing. This is where you find the artists write code and robots read body language. So we do things that probably not the normal, but we think creativity is very important, and we wear multiple hats as an artist, engineer, technologies, or designer. And we are always curious. So after today's talk, if there is a test, I want everybody to remember at least 2 things. Okay, so the first thing is that in Atlas, we believe in the best way to predict the future is to invent it, as nicely put by Alan Kay. So instead of waiting for people inventing things and we have to follow them, we should be thinking about the future and we can invent it. And I think the second thing is what I just said. We should be thinking about magic when we develop new technology. Okay, so I'm gonna give you a quick tour of the different labs and studios and show you project. Okay, so we have right now 8 labs and going to have like 9 labs as well. So we have lab on emergent nanomaterial. We have unstable design about fabric, textile. We have the living matter, personal healthcare, superhuman computing about accessibility, the Iron Lab, human robot interaction, and the type of studio that we play with words, and the Think Lab about things that transforming the future, and Acme Lab is my lab. Okay, so I'm gonna quickly give you the tool. So, and I will start with the emergent nanomaterial lab. So this is a picture of somebody having a tattoo, but if you have conductive ink, you will be able to power even the tattoo LED light. Okay, so here's another example. Let's see if you can see it. Okay, so there's a tattoo, and when you shine lights on that, then the tattoo shows up. But when the light disappears, you will slowly disappear. So there is a TED Talk, and I will share the slides so you can go visit them, about tattoos that give you superpower. So I like to share Carson's talk.
I have a background in chemistry, and I'm also really passionate about art. And there's a real connection between chemistry and art. I think chemistry is this really creative discipline. There's this famous quote that says, chemistry creates its own object. It's one of these sciences where you're not studying something that's already out there, you're actually making something. My name is Carson Bruns, and I direct the Laboratory for Emergent Nanomaterials. One of the projects that we're working on in my lab is what I call the Tech Tattoos project. And that project, we are using kind of nano-engineered particles as tattoo pigments that will change the function of your skin rather than the color of your skin. So for example, we have tattoo inks that will change color in sunlight. We have tattoo inks that will change color when they're exposed to heat. And we're working on tattoo inks that conduct electricity, like a tattooable wire. and we're interested in tattoo inks that can also sense other things, perhaps biological signals in the interstitial fluid of the skin. And yeah, I think the sky is the limit for this project. Tattoos can give you superpowers.
Tattoo can give you superpowers. Now, so don't worry, that's not human skin yet. Those are pig skin. But the idea is that if your skin tattoo is telling you this is too hot, you're about to get some burn, or your insulin level is too low, maybe you should get a shot, then your tattoo is giving you superpower to tell you what's going on. Okay, I want to go to the next lab. So this lab is called Unstable Design Lab. Because they're interested in design, especially textile, and they think all the design is not stable. There's no final moment, okay? So for example, this is fabric with chromothermic ink. And so when it's heated up, you can see that the numbers can show up, or the same embroidery, when the temperature changes, the different color appear. So you could be doing interesting stuff, and this is how the smart textile was weaved together. So it's very complicated. You put things together, you let it go. Then they are weaving in different threads that was dyed with different chromothermic ink. So as you push it up, then you start seeing some of the pattern changes color or disappear. And so in a way, you could make a wearable that change color depends on the temperature. Yeah, so some of the things disappearing already. Okay, so this is very interesting because then you're thinking about what would it be if your clothes is changing color gradually, depends on the environment. What if your wallpaper is changing color, depends on the climate. Okay, and then here's another project. This one is interesting because you saw the weaving that humans have to do it, and of course we have machine. So this project is trying to do a collaboration with natural. So you have all those tiny umbrella, and so when the wind blows, they're changing the things, and so your weaving pattern will change because you're collaborating with the natural, and that's very interesting. I will let you hear from Laura, the director.
What if our clothes could remember the things that happened when we were wearing them? What if it remembered the physical impacts on our bodies from certain engagements? My name is Laura Devendorf, and I am the director of the Unstable Design Lab. The work in textiles and smart textiles has offered a lot of different things in terms of new kinds of technologies, but also in thinking about who does innovation and who we think those kinds of people are, and different ways of just engaging with technology. You know, when it's in a thread or a fiber, it's very different than when it's on a computer behind a screen. One of the things that's been exciting is bringing the weaving community together with the engineering community on campus, which is becoming increasingly interested in smart textiles for applications like medical diagnosis or space flight. By creating a space for this work, we can show how craftspeople have really developed embodied relationships with these materials and structures in ways that are incredibly sophisticated.
Yes. So I think here's one example. So Laura is holding her daughter, and the idea is, for example, if your fabric is actually detecting which part she touches, right? So as she's growing up, you can actually have your clothes having a history of her growth. And this one is about your tie and thread could be detecting how you breathe and could be finding out before you're having asthma attack or stuff like that. And then of course, the important thing is also, how do you design this? So this is also where CAD, computer-aided design, come in. Laura is working on doing this thing called AutoCAD. So you can design your pattern, and she has a Jacquard room machine. And so you can have computationally programming them and then figure out what the different threads or sensor, and that you embed it. So each one of them could become a sensor or actuator. And so you could have a wearable that is totally weaved. Okay, talking about body and health. So the next lab, this one is interesting, it's called Living Matter Lab. So Marella is interested in personal health care. So instead of you having to send everything to hospital, what if just by looking at under the microscope or having your biofluid being detached, analyzed, all at the same place? Okay, so let me show you how it will work.
At Living Matter Lab, we're looking into how to take certain processes of healthcare and bring them closer to the patient. For example, looking into diagnosis, instead of you going to the doctor's office, have your samples taken and sent to the lab, we build devices that will help you do these things at home. I am Mirella Elister, leading the Living Matter Lab at Atlas Institute, University of Colorado Boulder. The specific technology that we're working with for now is in the realm of digital microfluidics. We call these devices biochips, and they are machines, small machines that move droplets of fluids. These fluids can be blood, urine, physiological samples. These devices help us automate the movement of fluids in a way that they replicate the exact procedure that happens in the laboratory, so that instead of having a lab assistant or a robot pipetting your blood samples, we can have a biochip moving a droplet of your blood and reacting with various regions to...
Yes, so that's very interesting. So the idea is that instead of you waiting to set your sample, have the hospital people doing analysis and come back a week, a month later, what if you can do your personal biochip that you can detect, you can analyze it right there? And in her lab, recently, they also work on this called mycodomicilia. So what they use is using mushroom and grow them, form them to make household objects like cell phone cases, jewelry, a bowl that you can eat, and all kind of stuff. So that's very interesting. Okay, next lab. So this lab is called Superhuman Computing Lab because they think besides people should have superpower, we should augment people maybe have different ability. So the idea is that we should invent things that are accessible, mobile, and wearable that for everybody of abilities, okay? So talking about jewelry, so one of the projects they did is they interview people and find out that, so for the hearing impaired, many of them would decorate and personalize their own hearing aid. And so the idea is that we don't just design technology for the function, we should also be designed form and function altogether, okay? And then here's another one. That one was for hearing impaired, and this one is for visual impaired. So quite often we'll be watching videos, and many of the video could have explanation about movable things, but the screen reader would just say, okay, something moving. And so the idea here is that there is this screen and maybe a person that demonstrating like dropping the ball at different times, and you could be having the little robot that demonstrate that on the tablet. So here's an example.
In the haptic video player, the robots are controlled using visual paths and optical codes displayed on the touchscreen. The user can touch or hold the robot as it moves to get non-visual access to the motion of important objects as they move in the video.
Right. So in their process, they also have a authoring tool. So you can download any video and then you can annotate, draw the lines, and then the robot will follow that. So quickly you make that into accessible video player for visual impaired. And here's another one for visual impaired. This one's called...
We have developed BrailleBlocks. BrailleBlocks is a tangible block and peg set with associated educational games on an interactive web application. One of these games is the animal name game. Parents play an animal sound. The child guesses the animal's name by building it with the blocks and pegs. The parent clicks the check word button to check if their child has built the correct word. The system outputs what word is spelled. BrailleBlocks uses tangible learning to create an engaging, collaborative learning experience.
Right. Okay. Quickly move to the next one. So now we're talking about the Iron Lab. This is interactive robotic and novel technology. They are working on human-computer, human-robot interaction. So what is the future of work and play with robot? So for example, here's one that's called virtual surrogate. So traditionally, you just control your drone and you have no idea what they're doing. But they are doing this virtual surrogate. So you know, I want you go there and I can see in real time, see through how the drone or the robot is moving. So you're having a kind of feedback and you can quickly understand where you are. So instead of you running the drone and having them fly into trees or running around crazy. Okay, I will let Dan, the director, to speak to you.
So robots are really exciting because I think they have a huge potential to help us in all sorts of different areas, from space exploration to manufacturing to home assistants doing our laundry or doing our dishes to search and rescue. I'm Dan Safer. I'm an assistant professor in the Department of Computer Science and the Atlas Institute here at the University of Colorado Boulder. I direct the Interactive Robotics and Novel Technologies Lab, which we loosely abbreviate to IRON Lab. We focus on improving the capability of robotic systems in working with people, and we do so in two major ways. On one hand, we look at how can we improve communication and exchange of information from people to robots. So we look at developing new computational models that capture user intent so that the robot can better assist them. And then we also look at communication the other way, going from robots to people. So how can we design robots that work more effectively with people, that people find more intuitive and natural to use?
Right. And so it's very fun because they have all kinds of different robots, and how do the robot communicate with people, and how do people communicate with the robot? So that's very interesting. Okay, next one. So this one is called Typo Studio because Joe feel like we have a lot of things we can play with language, with words. So for example, right. Do you still have that block in the middle? Okay, anyway. No?
Yes, you do.
Wow, that's bad. I cannot see it. It's not on my screen. Anyway, so I wanted you to see, for example, there or here, no, nothing, right? So playing with words, right? He or she, here or there. Because Joe found that interesting to explore how word means.
My work is an exploration of language and technology. So I like to look at the way that all kinds of technology shapes how we use language, how language communicates things, and how eventually language actually shapes us as humans. I'm Joel Swanson. I'm an assistant professor in the Atlas Institute, and I'm an artist exploring the relationship of language and technology. So right now I'm teaching a class on computational writing. So we're looking at natural language processing and a lot of other aspects of computational linguistics, but using them as tools for creative expression. So how can we use things like Markov chains to create unique poetic texts? And again, it's kind of looking at technology, but ways of repurposing it for interesting creative uses. But the other thing that I think is really exciting too is we're all learning really robust, interesting technologies. So I really like to integrate this notion of technology, right? Is it digital? Sometimes it's historical and analog, but it all kind of motivates my work.
Yeah, so you have he, she, or no, on, no, open. So it's a play with word. Okay, next one. So this one is called ThinkLab. And Think, actually I helped Daniel coming out with the name, Transformative Human Interfaces for the Next Generation. So that's spelled as Think, because they're interested in object and how everyday interaction could be improved, and maybe with the help of virtual or augmented reality. Okay, I'm gonna let Daniel talk to you.
If I make something with my hands, it's gonna look different than if I say were to design it on a computer using a mouse. Those are gonna be different objects. I'm interested in what are those differences and how can we build the best possible interface to really help us create. I'm Daniel Leitinger. I'm a professor here at Atlas and Computer Science, and I direct the Transformable Human Interfaces for the Next Generation Laboratory, short ThinkLab. And what we do at the ThinkLab is we want to make digital information tangible, building computer interfaces that will allow you to touch and interact with digital data directly using your hand.
Right. So one of his PhD students, Ryo Suzuki, actually work on interesting stuff. So this one's called Dynablock. So it's thinking about 3D printing, and because with a magnet, you can reuse them. They're interesting blocks, you know, the connection, so you can take them out. So this is printing a table, right? But when you don't want them, you just push them back. So each one of them can. So that's one. So here's another one, and I think this is related to architecture. The idea is lift tile. So instead of just small scale printing, what if we're doing large scale? Can you see? So this is the prototype. Okay, so now I want to talk to you about my lab. My lab is called the Acme Lab, and so Acme, this is a recursive. So Acme Creative Machine Environment, because we're interested in inventing the future about tangible interaction and how we support our work. All right, so the first project is called Mecha Magnet. So what you see here are 3D printed, embedded with permanent magnet. And let me show you the video. Yeah, this is so simple. And so no other gadget. What you see is what you get, but with embedded magnet. So by putting the magnet in different locations, you could pretty much create four different gadgets. Right, the two buttons, the on and off, and this one have, yeah, you put ball bearing with the magnet, like this. Yeah, so it's like fidget. It's very satisfying. So you can have a joystick and just use the magnet repelling. Okay, go back. And you can pretty much see where the magnets are. Right. So of course, this project started with, oh, we have a 3D printer. What can we do about it? Can we add things to make it functional? I like this on the slider. You have to check our field because that's true. Yeah, that makes sense. The attracting or repelling give you the sense. And I think this one is just moving in many different directions. Yeah, so there are many of them, okay? So the question is how do we do that? There are linear movement or polar movement or angular or planar or radial. We can have them attracting or repelling in the center and the edge, right? And so what does it mean? Like, depends on the magnetic field, then we can create different interaction that's haptic. We don't have to have complicated haptic glove. We can have physical object. So if we map off the terrain, like, oh, linear polar and all that, and attracting, so they could look exactly the same, but their interaction and the feedback would be very different. And so that's fascinating. So we can print a whole bunch of them. They look the same, but each one have a different function. And you may ask, why do we want to do that? Well, one thing is we can build toy. Right? So instead of complicated things, we can print it out ourselves, embedding the magnet inside. And yeah, he's taking it apart, so there's nothing glued together. It's all attached because the magnet is inside. Right? And so when you push, it goes back. Yeah, so that's one we can do toys. And then of course we want to do, we want to build a First game, and then we got Peter looking at the game and say, this is fun, let's do another game. And so they built this game called Hot Swap, all hands on deck, and they won the GDC. It's like one of the largest, like 5,000 people game design conference. They won the alternative control prize. And let me show you what the game is. It's pretty fun. So as you can see, this is all printed. This is a gadget. They build a Unity with parachute. Okay, all hands on deck. My input. So we have and each one of the gadgets. So for example. Like how do you coordinate? And so it's pretty fun. Okay, so that's that. And then I want to continue talking about a lot of things is actually talking about everyday object, could be interfaces, how we design everything we do. Okay, so for this, so I'm gonna do play even though you may have a block, but I want you to see this is a simulation. So I'm gonna go out because the idea is that, hey, we design a logo and we thought it would be cool if Atlas, each one of the A could be changing. It's still part of our logo. And some of you probably have noticed that each lab have a different logo because we can change the A, it's still Atlas. Okay, so that's one other way thinking about our everyday object is also an interaction that we can enjoy. And this one, this is Jiffer. So this is playing with the lamp. It's sonic. Pretty much program the sound to detect a different sound or different rhythm and maybe create a different color pattern for that. Here's another project. This one is called Jump Station because we thought it would be cool if we had allow people to distress, and this is building from PVC pipe and these are bucket And yeah, people can jump together, and then we have this central control, not control, the lighting showing up. So if you're in sync and the different color would show up, we got selected for Maker Made in the Boulder Library, so on exhibition, and people just go in and see that people have a lot of fun, and that's just everyday object. And here's another one. This one is called Delicate Paper Interfaces or Sensing Kirigami. And so the idea here is paper could be an interface as well. So we found some of the science laboratory carbon coated paper, and we realized that at the pencil. So that's a hint. Project that we continue on the paper, but we thought a lot of people are working on virtual reality, augmented reality, complicated things. And we thought, hey, it would be interesting if we can let people build paper interfaces, but with printed paper markers. So basically, you can paint it, or you can print it out. And so you have your computer or for your phone and look at the marker. You have the AR marker. And once you have that, you can have that generate anything that you are building. So we can see button paper, and this is the setting up because there are also these
Company A sold 20 apples. Company C sold 30 apples. Company B sold 1.3 times the amount of apples as Company C. Company X started the fiscal year at 22 points. Company X decreased by 36% in the second quarter. Push the buttons. Because it depends on where you go.
maybe get people to do things that delegate. Okay, so that's one. This is like every day. And then this one is interesting because the idea is that what if we can get robots to change the environment as we are in the virtual environment. And this is Roomba. The hanger up deck. So you can be inside of a robot to move around, but the robot right, you don't actually have to in the room. Okay, so one more. This one is called a ShapeBot. So little robots. It'd be cool if all the object we have is tiny little robot and maybe with paper as well. 3D printing and paper. They're very cute. Right, so you can see and this is basic paper. And then you can control them. Right. So this will be things that right? So when you move and everything moves. Well, let's say it's 3D printing. I mean, each one of the robot is 3D printed. What if I'm controlling the cat model and I'm extending physically? For a cat, they could be responsive. This one is like when you don't have a ruler, you have the ruler on that. The robot could do any little thing for you. Yeah, exactly. So they're communicating. So for number one, I want to be bigger. I think still keep on here. Or you can program it then. Right, so that's the angle. So on that, so what I'm talking about is making magic. And so a lot of things, this is where I am. You can find me. I will be happy to answer questions. This is where you come. And if you come to our demo, you will see all kinds of stuff. I want you to see the excitement if you come visit. And there are a couple projects as well. And then there are some projects that's from project to product. So I will end on this. So we are on time and I'm happy to get questions. I'm sorry, I cannot see the, the keynote things, but this is the screen. Okay. Yes, so I should stop sharing. Now we can have questions.
Well, thank you, Ellen. Perfectly on time. We do have 15 minutes for Q&As, and we are open to any questions from the audience. But first, I must say that I've never seen so many amazing work in 45 minutes. It's just a tremendous amount of work that you've done. And it shows how much energy and time is spent to producing all these amazing work. I remember from your very first projects, like the digital napkin and the right tool, the right time, that has scaled up to a lot of these amazing work that I've just seen. So while we wait for some questions, maybe I can start with one of my questions,
Sure.
if you don't mind. So we've seen that technology has impacted our fundamental behavior. And this relates back to the theme of this conference, how humans can change our environment and everything that we do, starting from some simple changes in behavior. And you've also gone through design schools. So my question is, having gone to a design school, how does that shape your research or your research interests and projects that you develop currently, and how has your research and your projects impact the design and the architectural practice? If that's a broad question.
Okay, so I think there are two parts of the question. So how is my actually architectural design training help me or give me the perspective of how I engage different projects? So I was trained as an architect, and I was interested in computer-aided architecture design. And in the process of that, so my project, electronic cocktail napkin, basically is a tool that I wanted as an architect. I like to draw. So cocktail napkin sketch is, and the right tool, right time is freehand drawing as an interface to knowledge-based system. So if I draw isometric view, then I will have a 3D model created for me because it understands which way is concave or converse. If I draw a spiral, I want to find information similar to that. So all of that is very interesting because coming as an architect and designer, I want the computer to help me do the work I want to do. I don't want to sit down and after I sketch, I have to turn to CAD and take the mouse and do XY, and to build that. So if I already sketched this isometric view shape, then computer should understand. So if I'm looking for a shape, I should be able to just draw the shape to find stuff. And so for me, that was 2D sketching. And from 2D sketching, of course, I want to go to 3D. So we're doing 3D sketching. And 3D sketching, that's in the virtual environment. And so I was working on virtual environment annotation. And from there, working into tangible interaction, because when we have screen with things that's moving and interaction, I found it very hard to control. So I want to take them out. And so one of the first projects I worked with students on a tangible navigational block. So we have who, what, when, where. As you rotate that, you can quickly change the interaction. So to me, every built environment is part of architecture. And so the fascinating thing for me is creating computational tool to help people explore their creativity, how they can interact with objects. And so I think the design training is how I approach everything, because I work on intersection between technology, people, and design. And so everything I do, the project is still the extension of that. Yeah, and what's the impact of building or architecture as a field? I think I was delighted there's so many sketch interfaces. And so one of my students from Georgia Tech was doing like sketch to BIM, because the idea is that, okay, maybe as you sketch, maybe you could connect directly to building information modeling. And I connect from sketch to virtual reality. So a lot of them is like a jumping stone from idea to realization. And so you see some of the robot or some of the fabric. And in a way, architecture is about material. So you could be thinking about fabric, And I think many years ago, there are people doing weaving. And I think this year, there's also somebody's doing weaving as well. And so you could change how the material behave, and that's all part of the environment. So I found that inform each other. And I've moved department from architecture to industrial design to computer science, because to me, it's not the discipline, it's about what we can create. And I like to call that as magic, because I think when we do technology and you have this curiosity and excitement, and that's like magic. Okay.
Well said, Ellen. Thank you very much. We have a few questions. Maybe I can start with this question. It says, how do you balance play and design for your applications? And these days, it seems that we need to promise more and more utility, but it seems that you are focused on play instead.
Well, I think there are utility, and we are not, okay. So I'm going to, as I said, I will share my slides, because one of the arguments is that to be able to make things is the part about creativity, right? And when we work on things, when we make things, we are playing with the material. We are having a dialogue with the material. So play is the important thing. So for example, the graphic designer talked about design and the play instinct. And that was really interesting, because if you have fun, then you are trying to achieve. So a lot of project we have is finding what to design, because we have the need. So like I said, for my electronic cocktail napkin, that was something that I wanted as an architect. I want to be able to draw. I want computer to understand what I draw and don't bother me with the things I don't want to do. And then if you see some of the tiny robots, basically, sure, it's playful, but then the idea is to think about, what if all the objects are intelligence? Like everything could be transforming, could be changing. So yes, they should have application, they should have utilities. Of course, I'm laughing with some of the robot utility, like I don't really need a robot to protect me from picking out my mug because it's too hot. But I think it's pointing out the possibility of what if everything you have here is transformable, right? So we're talking about building or space that could change, depends on the weather, the climate, depends on how many people. So maybe they could be transformable. And I think the playfulness get you think about things that's easier to accomplish because you're having fun. So, and everything I will show the slide, is all published in different places, because those are the places that people think we should explore the technology for 5 years or 10 years later. And they would have utility. So I'm not saying we don't want to. And I think play is a way to get people doing things. So what was the game? I mean, the trick that Tom Sawyer played, right? So he got punished, you have to paint the wall, and it's no fun. He said, well, I have the privilege to do that. Who want to play with this? So everybody come and painted the wall instead of he himself doing it. Because if you say, we have to finish this job, then nobody will do it. But then when this is fun and playful, then people will go into it. And then part of the process that in the development, they will find out more innovation. I mean, you look at the robot, they don't just come out from nowhere. The contribution is how to fix something smaller, how to get the things extend. Yeah.
Oh, yes. Thank you.
Okay.
We have 3 questions from the audience, and I'd like you to answer this live. So this is from Miriam. The small tangible input objects, sliders, buttons, wheels, etc., make a great user experience. Have you done any research to see how they can be integrated with the architectural CAD tools? For example, parametric modeling, Grasshopper. I guess this could make it tangible and more human-friendly.
Yes. So I had a student many years ago, and Sharif, I think he's now running the ASCAD. He actually did a tangible CAD. So similar to the robot, you move and play with the building block, and then the CAD will actually respond. And so I think the idea is that you could have object that's responsive to you, but meanwhile, it's also part of the process of the CAD. And so of course, that time he didn't work on Grasshopper or any of those. I welcome the connection or the link between the different software. And I think right now, some of the students, they are interested in building the first prototype or something to happen. And then some of the project, I mean, so in the last 3 slides I didn't show is like some of the project become commercial product. And of course, a couple of them could be like Lego blocks and they are robot, you can program them. So let's say if you have a whole bunch of brick, then you can program them and they are tiny little robot, they can self-assemble it, change, transforming, but maybe not having heavy equipment, but having something easily like the magnet, like the 3D printed banner block, right? So I think there are possibility for all kinds of applications.
Yes, I agree. Next question from Kyung Hoon Hyun. Amazing projects. Thank you for your presentation. It's very inspiring. Same goes with me. I have a question on the ShapeBot. How do actuators in the ShapeBot work? It seems like a very long paper extruded from the small module. Maybe it's rolls of paper. Would you be so kind to share the details? Is
Yes.
this IP protected?
No, actually it's published. So yes, so in my slides, when you got it, there's a link. So you can find the ShapeBot. And so the technical detail is all in the paper. So
Great,
we're
cool.
not hiding. And those are tracing paper. So they are
Oh, it's
roll
traced paper?
Yeah, those are tracing paper that go up and down. Yeah. So they roll inside into the little block, and when you pull, so you have something push. Anyway, it's very cute.
Another question from Pat. How does your work or outlook change the way you inhabit your home, your neighborhood, or the city? Oh, that's a scaled question.
How do my projects change the way I live in the city? All right, so that reminded me another project because we were talking about, so we were talking about, what was that? Okay, so some of you probably have watched like the House Moving Castle, right? So the idea is that you can move your whole building or you can move your whole neighborhood. And I think the Archigram also explored the idea about movable city and stuff. And so a couple of years ago, one of my students actually built the physical prototype, and the idea is that maybe the houses could move to the different neighborhood and responsive to the environment. So if there is too much water, they will go to another place higher up. And so you could have a responsive architecture, depends on the environment, the climate, and they could be moving. So you really literally could have, here moves the neighborhood, right? So a couple of houses, so each one of the house could be a robot, and there are a book and also exploration about architecture robotics. So what if architecture is like a giant robot, and each one of them, what are the things you can move? So I could have a transformable work environment. I could have transformable roof. Yes, so I think I see everything is changeable, and I see the opportunity that we can build tools to help people think about things, object, environment, and how that relate to each other.
Great answer. I guess this would be the last question. We have 1 minute. This is from Hyung Jun Park. Congratulations, Ellen. Any plan to go to Mars?
Well, funny you should ask. Right now, I don't have a plan, but a couple of years ago, we worked on a project that's called Space Lego, because the idea is that what if you create a space habitat, right? And we cannot bring a whole bunch of things. What if we can send the mushroom to the space and they can cultivate themselves? What if they become individual robots so they can build the houses? So I don't have a plan, but I think we're doing architecture, doing design, doing computation. We have the ability to help thinking about the future and design things and think about science fiction and become reality. So yes, cool. Don't have a plan yet, but I will be happy to go.
Well, I guess that's the time we have. I want to thank our first keynote for today, Ellen Zhou. I think this is a perfect talk to set the tone for this conference. Congratulations to winning the Zazada Prize. And I want to thank you again for being our first keynote for today. Thank you again.
Thank you. My honor. Have a good conference. Break.
So we will start our next session after we go through the 15-minute break. So I hope to see you in the spatial chat rooms. So feel free to join us there. And see you in 15 minutes. Thank you.
Are we in the chat room? No? Okay, bye.